Good afternoon. I'm Gillian Small. I'm really delighted to welcome you to CUNY and to the CUNY Advanced Science Research Center and to our program for inspiring women scientists, breaking barriers to success. I know we have people from institutions other than CUNY here today, so let me first say a few words about CUNY and about the Advanced Science Research Center. For those of you who are not aware, CUNY is the largest urban public university in the country. We have 24 different colleges and schools across the 5 boroughs of New York that house in excess of 270,000 full-time students and another 250,000 part-time continuing ed students. So our student body is approximately 500,000. Over the last decade at CUNY, we've embarked on a major effort to renew and expand our support for the sciences. And this includes building new buildings at many of our campuses, hiring new faculty in the sciences, and expanding the opportunities for our students to engage in science. The capstone of these efforts is this building that you're currently in, the CUNY Advanced Science Research Center, a place where we've located very high-end core facilities to support our researchers in 5 key areas: nanoscience, photonics, structural biology, neuroscience, and environmental sciences. There's approximately 1 floor of the building dedicated to each of those areas, and we're hiring world-class faculty to both lead research and bring together faculty from across CUNY to collaborate in these areas. For anybody who'd like to take a tour of the building, we'll be offering tours at the networking session later this afternoon. So around 5:15, 5:20, please go and sign up and you can take a tour of the building if you'd like to. We've run many programs to support women in science over the years, taking a slightly different approach each time, sometimes to support women in their negotiating skills, sometimes in areas of entrepreneurship. And just a note on the topic of entrepreneurship, Lynn Loacker, who I see in the audience here from the law firm Davis, Wright & Tremaine, who's another fantastic supporter of women in science, has asked me to mention a boot camp that they're organizing designed to provide business, legal, and practical guidance to help first-time women entrepreneurs build successful businesses. This is an all-day event in April of 2016. There will be some flyers at the reception desk. If you haven't seen them coming in, please take one if you would like. And Lynn, could you just identify yourself? So that's Lynn back there. So thank you for coming, Lynn. The fact that you've come today tells me that I don't really need to tell you the need for programming to support women in science. And all of our events are open to everybody. But sometimes we've taken different focuses, as I've said. And in the past, we've often focused on junior faculty who are just entering the first stages of their career. Today, we wanted to have somewhat more of a focus, although I'm sure junior faculty would also gain from the conversations, but a bit more of a focus on mid-career scientists and what it takes to move to the next level, what it takes to break into the inner circle, what it takes to go through to become a full professor or even a distinguished professor. We have a wonderful keynote speaker, who I will introduce in a moment, and 2 fabulous panels. The first of highly successful women who are not scientists themselves, but are closely connected to some of the best scientists in the countries. And each of the women on the panel have achieved very high status in their own right. And many of the issues to moving towards the top are the same, no matter what career path you're in. The second panel consists of some world-class scientists, and they will be sharing their journey and their thoughts and their insights with you. Before I go any further, I have to mention that to develop a program like this takes the hard work of many people, and I just come out here and take all the credit. But I really want to mention a few people who are heavily involved in planning today's event. First, Madeline D'Ambrosio, who oversees all aspects of event planning and many other things at the ASRC. Camille Sandersteven, who runs the programming here and has been in touch with many of you over organizing today, and Jonathan Vaughan, my chief of staff here at the ASRC. And also there's a group of women who've helped plan many of the women's science events over the years: Pam Brown, Louise Hainline, Jeanette Kim, and Mihaela Rabila, and I want to thank them for helping with this event also. So now it's my pleasure to introduce our keynote speaker. I first met Wendy Suzuki, I think it was 2012, when she was a presenter in the Cool Jobs children's program at the World Science Festival. And she totally captured the audience of kids by getting them involved in thinking about exercise and the brain and the effect that exercise has on the brain. And she got a group of these kids up onto the stage to chant about exercising and how it was improving their brain. And it was particularly interesting for me because my son was one of the kids that went up there. And he's usually very shy, but she got him up there. I've heard Wendy talk in many forums since that time, including her talk for the Moth, that if any of you are interested, I encourage all of you to sort that out online because it's an incredibly impactful talk. And she's also known for sometimes carrying a brain around with her. So I don't know if she has a brain with her today other than her own, but it's also something that really captivates the kids when they see that. In addition to studying exercise in the brain, Wendy also talks about how our brains allow us to learn and retain new memories for facts and events. She's published widely in all of these areas and has a new book, Healthy Brain and Happy Life. There will be copies for sale at the networking session, and Wendy's signature is in many of them. Wendy is a professor of neuroscience and psychology at NYU, and I'm really delighted that she's here with us today. Please welcome Wendy Suzuki.
Okay. Get my mic turned on. Okay? Oh, yeah, you can hear me. Thank you so much for that wonderful introduction, Jillian. It's such a pleasure to be here in this beautiful, beautiful building. So I was very excited when Jillian asked me to come and speak to you about both my science but also my journey, and particularly the people that have influenced me. So I have a very particular story because I have the story about the day that I realized that I wanted to become a neuroscientist. It's a very, very specific memory. It was the very first day of my freshman year at UC Berkeley. And I took one of those freshman seminar where you know, just a small number of students get taught by a full professor. And the freshman seminar that I took was called The Brain and Its Potential, and was taught by this amazing neuroscientist named Marion Diamond. This is a picture of Marion. Can you tell which one she is? Yeah, okay. Marion. So that day was very, very memorable because first there was Marion standing at the front of the classroom. Very tall, very beautiful woman, very athletic. She had a beautiful, outfit on with a white lab coat. But what was even more striking than her kind of rock star-like appearance, which I've always remembered it that way, was what she had on the desk in front of her, which was a hat box, a flowered hat box. And so the brain and its potential, she's telling us about the brain, and slowly and very dramatically, she opened that hat box, and with her gloved hands, she pulled out a real preserved human brain right in front of us. And that was the very first human brain that I ever saw. And I thought, that is the most interesting thing that I've ever seen. Not only that, she told us that what she was holding in her hands was the most complex structure known to mankind. It put humans on the moon. It invented the iPod, the iPad, all these different things. And it allows us to go from laughing to crying in 1 second in some situations. So, but what really got me was her descriptions of her classic experiments that she did in the late 1950s and early 1960s and continued until, was continuing to do those experiments in the 80s when I was in college, looking at, asking the question, how can the brain change in response to the environment? And to address that question, what she did is she decided to raise rats in what they called an enriched environment. Think of it like the Disney World of rat cages. Okay, so this is a picture from one of those early studies of a Disney World of rat cages. Lots of other rats to play with, lots of toys to play with. And she compared the brains of those rats to rats that were raised in what they called impoverished environments with just maybe 1 or 2 other rats and no toys. And what they found was environmental enrichment changed the brain in dramatic ways. It changed the anatomy, the physiology, and the function of the brain. And this was groundbreaking, because at that time, in the late 1950s, early 1960s, the idea was the brain couldn't change when you're an adult. Once you're an adult, that's it. No new neurons, nothing's changing. Here's what she showed. So what can the environment, changes in the environment, do to the structure of the brain? The outer cortex, this is a thin slice through a rat brain, and the outer cortex is out here, was thicker. They simply did a basic measurement of how thick the cortex is. They found it to be significantly thicker. Neurotransmitters levels changed. Noradrenaline, acetylcholine, the first neurotransmitter discovered, was increased in the cortex of the enriched rats. More synapses were found, not all over the brain, in certain areas, in the motor cortex, in the visual cortex, in the tactile cortex, the somatosensory cortex, that you can imagine might be enriched when you're living in Disney World. And more angiogenesis. Angiogenesis is the birth of brand new blood vessels in the brain. Good, because the more blood vessels, the more oxygenated blood can go to the structure that is the highest user of oxygenated blood in our whole body. More growth factors were found later in environmental enrichment. And a fact that I'll come back to later is, has to do with a structure that I've studied for the last 20, 25 years, a structure critical for our ability to form new long-term memories. This structure is called the hippocampus. And what not she, but others that carried on this work showed that environmental enrichment enhanced what we call hippocampal neurogenesis. In adults, the hippocampus is one of the few structures, one of only 2 structures in the brain, where new brain cells can be born. And exercise can beef up the birth of these new brain cells in the hippocampus. Environmental enrichment can do that. Well, I just thought, remember, I'm still a freshman, I'm still in that class, and I just thought, that is the most interesting thing I ever found. And I walked out of that class saying, I want to be a neuroscientist. Well, I went and I did my undergraduate. I worked in Marion's lab my senior year. I went to graduate school, and I decided to focus on my own version of brain plasticity, which is memory. This is a form of plasticity that happens every single day. If you remember one thing from this talk, if you remember my name is Wendy, or that I study memory and exercise, something in your brain has changed. That is brain plasticity. And I've focused on the structure that I told you about, the hippocampus, just showing you where it is. We cut away the side part of the brain, the temporal lobe. Deep in the heart of the temporal lobe is your hippocampus. You have one on each side. And really, my whole academic lab was built on studying this structure. I got my job at New York University because of my interest and my work in this structure, specifically looking at the patterns of neural activity in the hippocampus in awake behaving animals as they're performing different memory tasks. So then I'm going to jump to 1998, which was the year that I started at New York University. And I was the most excited assistant professor that you can imagine. I finally was able to start asking my own questions. And when I think back on my time during that period in my lab, and I think back on the interactions that were happening in my lab, I was building the lab, designing my experiments, hiring new people. The feeling that I get and the memory that I have of that time in the lab, the hippocampus means seahorse. This just shows that here's a human hippocampus. It looks just like a seahorse. But back to the feeling in the lab. The feeling in the lab was something like this. A dinner party, a great dinner party that you never want to leave, because there's always somebody interesting to talk to and always something fascinating to talk about. That was the feeling that I had when I first started my lab at NYU. But a few years in, I have to say that in contrast to this dinner party-like atmosphere in the lab, if you asked me, Wendy, how's your social life going? It would look more like this. Imagine tumbleweed, blowing in this desert. So I I worked all the time. I had lots of colleagues in the lab, but no friends outside the lab. I only ate takeout, and a few years in, I was 20 pounds overweight, and something had to change. And it was actually another very vivid memory. I went on a whitewater river rafting trip in Peru. And this was my wake-up call to really tell myself, okay, I need to change, because I was the weakest one on the whole trip. I was in my 30s. I was healthy, but very, very, no upper body strength. I didn't work out at all. And there were 16-year-olds on that trip that were stronger than me, and 65-year-olds on that trip that were stronger than me. And I came back and I said, okay, I don't know how to, make more friends, to deal with the social life, but I do know how to get in shape. I'm from California, after all, so I went to the gym, got a trainer, and I got exercise into my life. And so the title of my talk, which I jumped over, is the disruptive power of exercise. And this is my first example of how exercise was disruptive in my life. Because first of all, I have to say, exercise didn't change overnight. It's like I just didn't go to the gym and suddenly it changed. It took a year and a half of regular work. But I have to say that after that time, I built a regular exercise practice, and I noticed several things. One is my mood went through the roof. My energy was much, much better. I used to think that all I have to do is put my head down and work all the time, and I would be maximally effective and maximally energetic. That was not true. But the thing during this time that really motivated my regular exercise going was a class that I discovered at the gym that I go to. It's Equinox Gym in New York City. It was a class called Intensati, developed by a really famous or really popular exercise instructor here in New York City named Patricia Moreno. Has anybody heard of Intensati? Okay, great. So I went to this class. This class was like no other class because it pairs physical movements from kickbox and dance and yoga and martial arts with positive spoken affirmations. So in the class, you don't just punch back and forth. You say, I am strong now. And the whole class is yelling out these affirmations with a whole bunch of other sweaty people. So by the end of the class, what happens is those positive affirmations get in, and you're walking down the street, and you're like, I am strong now, all week until you go back to the next class. Anyway, this class really got me into regular exercising in a very good way. And so here I was, my mood was better, my energy was better, even my social life improved because I met a whole lot of new people at the gym. But the most amazing thing that happened from this experience was something that I noticed at work. Something that I noticed at work when I was writing my grants. I noticed that my attention was deeper and lasted longer than it had before. And not only that, my memory was better, so I was able to remember all those points you have to remember from all those papers you just tried to read to get an understanding of the literature. My memory was better than it used to be. Writing is always hard, but writing, I noticed in myself, was getting a little bit easier. Again, related to the exercise. So this was the first disruption. Exercise improved my energy, my mood, my social life, my memory, and my attention. So that was disruption number one. I'm sorry. So this is my example. My social life went from that to this, so it's very good. Disruption number one, exercise transformed my personal life, but it quickly led to disruption of exercise number two, which was how it transformed my career. So the first thing that happened is I'm noticing all these changes in my own ability to do my science. And of course, I go back to the literature. I'm a neuroscientist. I want to know what we know about the effects of aerobic exercise on brain function. And what I find is a growing and exciting literature on the effects of exercise on the brain. For example, we know that exercise increases many of the different neurotransmitters that are decreased in depression. Exercise increases serotonin, noradrenaline. It also increases dopamine, which is a neurotransmitter very important for reward. When you win the lottery or you eat a great bar of chocolate, dopamine increases in your brain. Endorphins also increase in your brain with exercise and has been associated with, endorphins are the natural morphine, so it's kind of like a painkiller. And it's been associated with the runner's high, as we all know. So these are scientific studies, neuroscience studies on the effects of mood. It turns out that the most common finding in humans when they study the effects of exercise in all age groups is that exercise can improve your ability to focus and switch attention. Those are findings in humans. But then something interesting happened when I went back to look at the literature in animals, to look at what the effects of exercise was, and step back just a little bit to say, well, where do these studies come from? I found a very familiar face. The face I found was Marion Diamond, because it turns out that those studies that she did way back in the 1960s showing that enriched environments changed brains led new researchers to ask the question, what was it about that enriched environment that were causing all those striking brain changes that she so elegantly demonstrated? Was it the social aspect? Was it the particular kinds of toys? And what they found was the majority of all those brain changes were caused by one thing: exercise. All you have to do is give rats that exercise wheel, and you get most of these changes. What changes do you get? This was my list for environmental enrichment. It turns out that exercise changes all of these things. It can cause increase in cortical thickness, changes in neurotransmitter and growth factors levels, more synapses, angiogenesis, and a stimulation of hippocampal neurogenesis. Now think about this for a second. How many people want a better memory in this room? Okay, I've just told you that aerobic exercise can stimulate the growth of brand new hippocampal cells in your hippocampus. Some of you might think, oh, that's bad. I don't want new cells. It might disrupt my old memories. But it turns out that would be wrong. That would be a very smart thing to say. But we know that in rodents, exercise does improve a range of different hippocampal-dependent memory functions: spatial memory, pattern separation, which is a fancy way of saying memory encoding, and contextual fear conditioning, that is memory for context, are all significantly improved in rats that just are given access to an exercise wheel. So again, if you think about motivation, this is my motivation to go to the gym. I want more hippocampal cells. But again, this was the point where I was just looking at the field, and I thought that was fascinating. I wanted to learn more about this. And so I said, well, I know as a professor of neuroscience at an undergraduate teaching institution, I knew the best way to learn about a new topic area is to teach a new undergraduate course on it. So I decided to teach a new undergraduate course called Can Exercise Change Your Brain? And because exercise inspired the development of this class, I decided that I wanted to try and bring exercise into the classroom so that I would make the students exercise, and then somebody would make the students exercise. I'd bring an exercise instructor to do that, and then I would tell them about all the effects that they were experiencing from that exercise on their brain. And so I thought that was a great idea. I went to my administration and I said, I have this great idea. Can I have some money so I can hire an exercise instructor to come and teach this class with me? And they said, well, we hired you to teach the class. There's no other funds for that. So I did the next most obvious thing. I decided to go to the gym myself and become a certified exercise instructor, which is exactly what I did. I actually ended up training for 6 months to learn how to, first I took the teacher training. I trained for 6 months because teacher training was just 1 week, and you can't learn how to teach a class like this in just a week. So I trained and I practiced with all my friends. And as I was practicing, and of course during the 6 months I was developing the class itself based on all these readings that I was already doing, because I was fascinated about the effects of exercise on my own brain, I realized that these students were the perfect subjects in my first human exercise study, because they were going to be exercising more for the whole semester. So I added another component. It was a research component. So this class was going to be once a week. They would do an hour of intensati, followed by an hour-and-a-half lecture discussion about what exercise was doing, developing new experiments to test the effects of exercise on brain function. And at the beginning and the end of the semester, I would test them cognitively on a range of memory tasks, including memory tasks, sensitive to the hippocampus. And not only that, I got my colleague who was teaching a neuroscience elective class to allow me to test his subjects, test his students as well. They weren't going to exercise. So I'd have a real control group. So there I am, 6 months training to actually teach this class, developing the class. And I remember that day was September 9th, 2009, and it was the first day of that fall semester, and I walked into the classroom, and this was the classroom that I taught in for the last 11 years, many, many traditional lectures. But there were a few things that were different that day. First, I was clad head to toe in my best Lululemon. All spandex, right? So that was a little bit different. Second, I was a little nervous. And I was never nervous. I don't get nervous. Well, I do get nervous sometimes, but giving those kinds of lectures, I never got nervous. But I was nervous. I'd never taught my undergraduate students exercise before, so I was a little bit nervous. And the third thing that was different was that students are usually a little excited, maybe a little nervous for the class. These students look scared. I mean, I think it was all my spandex that I was wearing that scared them. And you can tell in their eyes and from all the nervous laughter that they actually weren't sure that they really wanted to be in this class and sweat with their professor. So, but there was no way to know whether this class was going to be a success or not than to actually do it. And so I told them that we were going to be doing this workout, Intensati, pairs physical movements from kickbox and dance with positive spoken affirmations. That's all you need to know. All you have to do is follow me. And so kind of to give you a feeling for what that first day was, I'm going to ask you all to stand up. Please stand up, because we're going to do 3 minutes of this so you can really get a flavor. Okay? 4, 3, 2. Punches right and left, right, left, right, left. I can see you all whether you're doing it or not. Okay, excellent. Here we say, I am strong. You say, I am strong. I'm so strong. You say, I am strong. You say, new move, uppercut, up, 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 up. I am inspired. You say, I am inspired. You say. Back to strong. I am strong, you say. Inspired. I am inspired, you say. Strong. I am strong, you say. And I'm inspired, you say. Push it out. Push it. Go. Push. Okay. This is called desire. Here we say, I am pumped up. You say, I am pumped up. I am pumped up. You say, last time, I am pumped up, you say. Last move, it is pull it down, pull it down, pull it down, pull it down. Do it like you mean it. Come on. Good. Here I say, I am on fire. You say, I am. Again, I am on fire. You say, last time, I am on fire. You say. From the top, I am strong. I am inspired. Push it out. I am pumped up. Pull it down. And I'm on fire. Done. Good job. Okay. I want you to think back on your college career and think about the imagery of doing that with one of your professors. Right before class, right before every class. So I'm coming back to this theme of the disruptive power of exercise. And this is where I found exercise to be disruptive in my career. So this class and the energy that we generated in yelling out all those affirmations for a whole hour just flowed into the academic part of the class, such that that class was the most interactive, most engaged class that I had ever taught at New York University in those 11, 12 years that I had been there. And in fact, it's transformed the way I teach every other class ever since that day. But then something even more kind of disruptive happened. That is, I got the results from the outcome of that experiment that I said I did in the context of this class. So what happened, remember, it was just once a week they were exercising. It was mainly to give them some data that they could kind of chew on and play around with in their experimental kind of design aspect of this class. But what we found was even just once a week of increased aerobic exercise in these classes, this is pooled from 2 semesters that I taught the class, significantly improved their reaction times. Students got significantly faster at responding correctly to the memory test. They didn't improve on their memory test, but again, it was only once a week. And I thought, oh my gosh, if I could get that with just once a week increased aerobic exercise, what could happen if I could test them 3 times a week, 3 or 4 times a week? What would happen then? And it really got me thinking. By this point, I was about to be full. I just became full professor, focused again on the memory research that I was doing. But it really made me sit back and think, what am I more interested in? What excites me? What do I think about when I get up in the morning? And it was the exercise results. What can we do? Because it had so many implications that I'll get back to in a second. And this was kind of the first generation of my desire to switch my whole research program, which was an unusual thing to do. Once you finally get to full professor status, you have your reputation, you have all your colleagues. And it was, I usually just gloss over this point, but it bears a few more sentences. It was a very scary thing. Because I knew the answer to the question, what excites you when you wake up in the morning, what do you think about? It was clearly the exercise stuff. It wasn't that I wasn't interested in memory anymore. It was just I was more interested in exploring that. And all these things kind of went through my mind. I'm not going to go to the same meetings again. I'm not going to see all my same colleagues, my friends. I'm not going to have any more friends anymore. And of course, that wasn't true. But it's scary because it is your scientific identity. But then I thought, one of the most valuable things that we have as academics, and especially tenured academics, is they say you can do anything you want. Most people stay and do variations of that. And I thought, this is an opportunity to test that and see what happens. And so my last postdoc in the memory work is finishing about a year from now, and then the whole lab will have switched over to doing exercise studies. So that is definitely happening, and I'll tell you why. I think these studies are so interesting, and I just want to tell you the study, the main study that we're doing right now. And then I'll tell you why I'm so excited about all of this. So we want to look at not just once a week aerobic exercise, but really looking at changes in cardiorespiratory function and correlating that with cognitive changes. And so what better way to really get your heart rate up than to do indoor cycling? And we've partnered with a great indoor cycling company called Swerve on 18th Street near Union Square. And they donated all the classes so that we can test 30 people that are increasing their aerobic exercise from less than 30 minutes a week to 3 times a week doing their 45-minute spin classes for 3 months. And we're comparing them against, I should say that Swerve, the great thing about Swerve is everybody has a gimmick. Swerve's gimmick is you ride as a team. And so you go into class and you join the red, the blue, and the green team. And their bikes are set up to calculate your basically energy expenditure. And those are calculated online, and you can compete as a team. So the red team, all the bikes together have this energy output, and all the blue bikes, and so you can compete as a team without saying, okay, Wendy has a 12 energy output, and Sally has a 24, so you don't feel bad. So you have, we have 32 people doing cognitive testing before this 12-week, 3 times a week workout. We're basically in the middle. We have about half of the exercise group doing. And our control group is competitive video gaming, because there's a social component, there's a competitive component. This isn't Wii training, it's very simple 2D games. But we get a lot of good competition going in the lab for the video games, and all the undergraduates play their competition. So undergraduates love working in my lab because they can play video games as part of their research program. So these are the first studies to really look at an intervention. Because what we really want to know is how much exercise, how long do you have to exercise? Actually, most people want to know, what is the minimum amount of time that I have to exercise? And then how long does it last? So this is where we are. We know that exercise is good from all those studies that I told you, but then everybody says, well, Wendy, tell me just tell me how much to exercise. What about kickboxing? Is that good? And then I have to say, I don't know. These are the studies that we want to try, and very practical studies. And the last component is very, very important because, and this is an idea that was only recently appreciated. So I've told you that the hippocampus is critical for long-term memory. Another way of thinking about memory is thinking about the past. Memory is the act of thinking about the past. Well, recently, people have discovered that when you have damage to the hippocampus, you're not only impaired at thinking about the past, but you also appear to be deficient at thinking about the future. That is imagination, imagining possible scenarios. Because think about it, imagination is putting together all those things in your memory in new ways. And so this was first discovered in 2007, where a very, very clever neuropsychologist at University College London asked patients with hippocampal damage not only whether they were memory impaired, which they were, but she asked them, can you imagine a tropical beach? None of them had been to a tropical beach. And she had controls that had the same education. And the controls could describe, the fruity drink and all the boats and everything. And the patients with with hippocampal damage had a very, very difficult time. This was not a language deficit. They had no deficits in their ability to understand or put together sentences, but they just couldn't generate some new thinking about the future. And this raises the possibility that if the hippocampus is important for aspects of imagination, a key component of creativity, that in fact exercise, which is enhancing birth of new brain cells in the hippocampus, may also be enhancing creativity along with long-term memory. So now, just to conclude, I want to say there's a third disruption. So I've been telling you about this cascading set of disruptions. The first disruption was a personal disruption. The second disruption was a career-wide disruption. And the third disruption, I think, is the most important because it really happens at the level of society. And this is really why I'm so excited about this area of research. Because exercise, and all these studies that have been done on exercise, really suggest that exercise and our understanding of it can change the way that we live and the way that we learn. What do I mean by that? I mean that all these studies suggest that instead of taking away physical education from our school system, we need to put it back in, but put it in a reasoned way based on neuroscience research. It means that instead of, or in addition to searching for that pill, do you know there's a new series called Limitless that's going to be on this season where he takes a pill and gets really, really smart? In addition to looking, I'm happy to have a pill. But in addition to be thinking, to searching for that pill, we should be searching for the optimum exercise regime that's improving all of these aspects of our brain that we've talked about. And then something that, of course, addresses and affects every single one of us in this room, and that is, how do we enter older age with the strongest brain possible? And my answer is aerobic exercise. Well, we don't maybe know the prescription right now. We know it's very good. And people say, oh, but you can exercise. Can't you exercise too much? And I have to say, yes, but we're very unlikely to be exercising too much. I mean, you really have to try hard to exercise too much. Most of us just will be maximum to just get up on the high side of the curve. So that is why I study exercise. But I want to try and bring it back to where I started, which is this inspiration. So everybody gets inspiration from someplace. I got it from Marion Diamond. And she's influenced all of her approaches and thoughts and fascination with plasticity really were kind of transferred to me. I didn't mention it, but she's not only one of my favorite professors, but if you go to Google University, her lectures on Biology 101 is one of the top 5 downloaded lectures all across the university. She's an amazing instructor. And I have to say that today I have my own hat box. And I kind of use it in my classrooms because it is such an engaging way to get people interested and thinking about their brains. And it really is also just an homage to her and a way to bring her into the work that I'm doing right now. So I'll end right there, and I'm happy to answer any questions. Thank you.
Thank you, Wendy. I think we've learned a lot of things from Wendy today. But some take-home messages I've taken are: be brave, be self-assured, and don't be afraid to be different. I'm sure you've learned a lot more things. Please, questions I'm sure Wendy would be happy to answer.
Yes?
Were there sex differences in your groups?
This study, the SWERV study, is still going on. We are taking both men and women. And this first study, I'm not sure we're going to have enough to look at sex differences. What we're really interested in getting at are gene differences, because there are different alleles. One of the growth factors that is significantly affected by exercise is brain-derived growth factor. And there are 2 different alleles. You can have a VAL allele for BDNF, and that gives you full benefit from BDNF. But if you have a MET allele, you have significantly lower memory scores on that. And so we're asking whether exercise can help bring those MET alleles. We want to, in the future, ask whether exercise can bring those MET allele populations up to the normal population.
And what about differences in the classes you compared?
Yeah.
Teaching?
Yes. So one thing that I didn't mention is that I thought I was doing an exercise study. It turned out to be an exercise and stress study, because we were testing them at the beginning and at the end of the semester. And what happened was the control class that wasn't exercising, they actually got worse on a number of different tests at the end of the semester. What happens at the end of the semester? It's right before finals. And I don't know about you, but you can just walk through the NYU campus, and it's like thick with stress at the end of the semester. And my students tended to stay. This was the memory effect was not significant, but the trend was the control group went down at the end of the semester. My students stayed the same. I don't think we had quite enough exercise. We didn't have quite enough students. And this was in classroom. It wasn't completely randomized control design. But those are some of the things I'm learning. And we're continuing our studies with students. Yeah. Yeah, too small sample to get sex differences. Yes?
Is there any evidence of any epigenetic happening in terms of methylation patterns?
I'm sure there is. There are lots of really interesting studies suggesting that exercise is affecting epigenetics. But I think it's way too early to make any predictions about that. Yes?
Another question. Trying to compare it to the type of exercises, does it really have to be aerobics?
Yeah.
Or could you compare it to another group that, let's say, if you're doing it for an hour, just with great music like rock and roll or something,
Yeah.
and you're just in good mood and in euphoria or something like that, and you still come out with a great
Right. Yeah.
feeling.
Right. Right.
So I would compare it to some of this. Sometimes, like I'm doing from my own experience,
Mm-hmm.
when I dance for an hour, I'm in another land
Yeah. Well, dancing is aerobic as well, but that's a critical question. So what is it about it? And that's one of the things that I want to do with these studies. I want to try and categorize. So we're going to be paying close attention to your heart rate during these kinds of exercises. So I can't control what everybody does, but what I want to try and do is say, with this level of heart rate, for this amount of time, you're going to improve on these three things. One of them's mood, one of them's memory, one of them's whatever. But if you go higher, you get a different. If you go lower, you get maybe the first one that comes up, which may be mood. And I think that there's going to be lots of interesting variations, not just with things like dance, but of course things like meditation as well, that are also affecting the brain in a very interesting and somewhat overlapping way, but also distinct.
The reason I was saying is because, for some people, exercise, it's sometimes, like they have to.
Yeah, bad word, right? Yeah.
They say dance,
Exactly.
fun.
Right. Exactly. Movement. Yes.
Do you plan to add an assessment of gene expression before and after?
I would love to. Yeah. We're thinking about those. We're actually writing those experiments right now, those grants right now, and trying to figure. There's such a wide range of different things that we can look at that have some preliminary evidence from animals, but all of our studies will be in humans. But part of the goal is to kind of try and do this kind of research in a very different way, in an entrepreneurial kind of way, so that we're not just going to be doing a simple kind of, or traditional, I should say, traditional kind of NIH or NSF funded kind of grant, but we do it on a population level and have people, thousands of people coming in, because turns out people like to find out their cognitive outcomes on these kinds of tasks. So that's the goal. And if we're there, if we can get that going, then we have a good shot of doing lots of different things. Yeah.
Changing fields to a different topic.
Yeah.
Do you find any resistance to the already established people? Because there's a lot of laboratories already researching exercise and cognitive function and,
Yeah.
and animals. Do you applying for grants in a new field? Do you find resistance? And so how did you navigate that? 'Cause I know it's
Yeah.
clicky.
Right. I mean, so I've been very successful at getting small grants. We're just now starting to apply for the bigger grants. And the thing is with exercise that I found so fun is that there's so many other outside agencies that are interested in helping fund. So I got all the funding for this Swerve study from Swerve. Nike, I'm talking to next week. There are lots of companies that are very interested in finding out these results. So I find it opening things up. And I can't really answer because I haven't, been rejected from grants, from the big grants yet. So I'll let you know. Hopefully that won't happen, but.
Wendy, can I ask a follow-up question?
Yeah.
How do you have colleagues in your own particular field, and then
Yeah.
you're changing not completely but somewhat the
Yes.
field.
Yeah.
How did your colleagues react to that, and were you accepted by your colleagues in that?
Yeah, they're like, I'm okay, you're okay, don't. They're like, oh, freed up animal space in the animal colony. That's great. And yeah, I didn't find any. There was definitely, it was not, oh my God, that's so great, but it also wasn't, you can't do that. I never got that. It really was an open kind of atmosphere. So that part was good.
Are there any other questions? In that case, please join me in welcoming and thanking Wendy again.
Great. Thank you.